When designing wearable wings, a very important consideration is the wing's directional and lateral stability. This is vital because the wings have no vertical or horizontal tail surfaces, so the wings themselves have to provide all stability. Now, Mother Nature knows about this very well. A good example is the fruit bat. It has no vertical tail, no horizontal tail. They do fine. I've decided to make a model of the wing and try it out using the plan form that results from an optimum lift distribution by putting the pilot where I want the pilot. Experimenting is really important, and often I feel overconfident and rush off in a certain direction without considering the consequences. I have two wings built now. It'll go something like that. This model laid out on the window ledge. This gap here is to allow the wing to sweep back and forth. This model has a very simple feedback stability system in the form of these little pieces of plastic which act as springs. They set at an angle so that as lift increases, the wing sweeps back. This piece of plastic illustrates it's flexible. Essentially the system that's used in nature. In this case, a very simple mechanical feedback system. I'm in the process of making yet a new wing. I have these cutouts and pieces of reject prototype feathers, and so I'm cutting out pieces to make the wing. The new wing is slightly different from the one I made before, and this will enable me to compare new profile, which is a photo of a hang glider harness, and is therefore a very realistic shape as to what the wearable wing will look like from the side. I'm not too happy with the results of using this soft foam to shape the pilot's enclosure. It's too rough for my liking because I want to take photographs of the model to illustrate what it looks like. This piece of packaging styrofoam should be good. It's comparable with two layers. I think I can make a suitable piece. Carve it, and I think it'll look much better. It's light. It'll be reasonably tough. The trampoline with two planks laid upon it is a good way to cut this foam. It's a long process. I've carved out the styrofoam and glued a strip of cardboard there. I have made a second inner here such that the wings lean in and when lift is applied, they sweep back. Wing stubs will be glued on, but before that I will extend the wings here. The wings come off fairly easily, which is important. Progress, yes. Slow, yes. Center section here, which will be attached to the body, is set at an angle here to simulate the angle of the upper arm. I'll adapt the center section here onto the wingtip, the feathers, full scale. Well, here's the model finished. I've tied the wings so that they don't sweep back and forth, just for the photos. Outside there's a rather strange light. The wind is from the northwest and it's really quite calm. I have a picture of a female pilot with the wings. I prefer a pilot of about 50 kilograms for the first flights, because a lighter pilot flies more slowly and therefore it is safer. So I would love to find a nimble young lady who would like the experience. I prefer a young woman who's a gymnast or a dancer, a woman with an educated body. I prefer not to have a trained pilot, because using Mother Nature's stability system results in a control system that behaves differently from aircraft and hang gliders. So I don't want someone with the wrong conditioned reflexes. The process of testing will be very gradual, and so that the candidate, the pilot, will learn to fly slowly and gradually.